All right, let's dive right in. Today, we're going to journey thousands of years into the past to see the night sky through the eyes of ancient India's Vedic seers. We're going to decode the absolutely incredible astronomical knowledge that's been hiding in plain sight inside some of the oldest texts in human history. And what we'll find is a world where science and myth weren't just related, they were basically the same thing.
So, let me just ask you this. When you look up at that huge dark sky, what do you see? Do you see the hard facts of science, orbits, gravity, nuclear fusion? Or do you see the timeless stories, the myths and legends that people have been telling for thousands of years? Well, for one ancient culture, you didn't have to choose.
And that right there is the key to understanding everything. The people who composed the Vedas, they didn't see any conflict between collecting data and telling a great story. They had this unique way of looking at the cosmos, a lens that brilliantly fused together super careful observation with these deep, meaningful allegorical tales.
Okay, so the first part of this lens is something we can call scientific naturalism. This was the absolute bedrock of their astronomy. The Vedic seers were incredibly sharp observers, and they had this core belief that you describe exactly what you see. No more, no less. So their texts are just packed with these vivid first-hand accounts of what was happening in the sky.
But here's where it gets really cool. They took that direct observation and they wrapped it in allegory. They gave personalities to the things they saw, the sun, the moon, comets, and they turned their movements into these epic stories. And this wasn't just for fun, it was a seriously powerful way to remember things. Think about it. It was a way to encode and pass down complex scientific knowledge from generation to generation, all by word of mouth.
So this all sounds great in theory, but how did this dual lens of science and story actually work in practice? Well, let's put it to the test. Our first case study, those fiery messengers that streak across the sky, comets and meteors.
The descriptions you find in the Rig Veda are just unbelievably vivid. They talk about Keshins, which literally translates to the long hairy ones. I mean, is there a more perfect description of a comet's tail? They also use the term Dhumakatu, which means smoke-bannered fire. This isn't just a myth, it's a precise poetic snapshot of a real event. You can almost feel the awe of the person who first saw that and wrote it down.
And this is where the two sides of the lens just click together perfectly. The texts tell these stories of the Maruts, these storm gods who come crashing down from the heavens with so much force they can shatter mountains. But when you look at it through that scientific naturalism lens, what you're reading is a stunningly accurate account of a meteorite shower. The myth was the delivery system for the scientific observation.
All right, if you thought that was cool, get ready for our next case study, because it takes things to a whole other level. We're going from random events like meteors to the predictable, cyclical, and kind of terrifying events of eclipses. And let me tell you, the code gets way more sophisticated here.
So the story is super dramatic. There's this demon, an asura named Swarpanu, and he attacks the sun and swallows it whole, and suddenly this terrifying darkness just falls over the entire world. It's this classic cosmic battle of light versus dark, but, as you've probably guessed by now, with the Vedas, there's always more to the story.
And in this case, the clue is hiding in a number that just kind of pops up in the Rig Veda whenever it talks about these celestial battles, 3339. For centuries, this number was a total mystery. It's so specific it seems completely random. What on earth could it possibly mean?
Well, this is where the hidden genius just blows you away. Researchers now believe that 3339 is a long count of nights. Now stay with me here. If you double that number, you get 6,678 lunar days, or tithis. And what's so amazing about that? That number is almost the exact length of the 18-year Saros cycle. That's the period after which eclipses start to repeat themselves. This isn't just some random number in a story. It's one of the earliest records we have of humanity calculating the rhythm of eclipses, all hidden inside an epic tale.
Okay, so we've seen events that happen in a flash, and cycles that take years. Our third case study deals with an observation so slow, so incredibly subtle that it takes thousands of years to even notice it. Let's talk about the pole star. The Vedic texts talk about a special star they called Dhruva, which means fixed or unmoving. This was their celestial anchor, the pivot point that the entire sky seemed to turn around. And they knew exactly where it was, at the tail of a constellation they called Shishumara, which we now know as Draco the dragon. But here's the thing about our planet. It wobbles. Yeah, like a slowly spinning top, the Earth's axis traces this giant circle in the sky over about 26,000 years. This is called precession, And it basically means that the star that marks true north actually changes over thousands and thousands of years.
So let's put this on a timeline. Around 3000 BCE, a star called Thuban, right there in the constellation Draco, was almost perfectly lined up with the North Pole. It was Dhruva, the fixed star. But then, fast forward to around 1800 BCE, and these incredibly meticulous Vedic observers, with this tradition passed down through generations, noticed something that should have been impossible. Their unmoving star was moving. They actually recorded that Dhruva was no longer fixed, it was drifting away.
And you don't have to take my word for it. We have the proof right in the text. A king, Brihadarratha, literally asks a sage this profound question, wondering why the fixed star drifts. Think about that. This isn't a mythological mistake. This is a direct, recorded observation of the effects of axial precession. It's a scientific question born from centuries of patiently watching the sky.
So we have this incredible library of celestial knowledge. But the big question is, what was it all for? This brings us to our final section, where all of this cosmic observation gets brought right down to Earth and turned into applied science.
You can almost think of it as their own kind of scientific method. First, you observe the heavens. Then, you symbolize that knowledge. The heavens, the path of the sun, that gets represented by a circle. The Earth, stable and ordered, that's a square. This pushed them to develop some unbelievably advanced geometry, which they wrote down in texts called the Śulbasūtras, and it was all for one main purpose: to build ritual fire altars that were like miniature, perfectly aligned models of the entire universe.
And the math they came up with was just extraordinary. Get this quote from the Vajrayana Śulbasūtra. It's a clear geometric statement of what we now call the Pythagorean theorem. And this was written centuries before Pythagoras was even born. This wasn't just math for math's sake, it was a practical tool for sacred engineering.
The ultimate goal was this ritual act known as squaring the circle, constructing a square altar with the exact same area as a circular one. Now, this might sound like a geometry problem, but it was so much deeper than that. By geometrically unifying these two shapes, they believed they were ritually unifying the earth and the heavens, bringing cosmic order right down into their own sacred space. It was the ultimate application of everything they knew about the stars.
So what the Vedic texts really show us is that the line we often draw between myth and science can be incredibly blurry. Sometimes it's not even there. And that leaves us with a really fascinating question. How many other stories from the ancient world aren't just fairy tales, but are actually sophisticated scientific records? A sky full of stories just waiting for us to learn how to read them again.